Hey everyone, and welcome back to The Explainer. Today, we're diving into a batch of source material that tackles a seriously high-stakes engineering dilemma. Over in global manufacturing circles, it's often framed as 如何选择中选错类型, which basically translates to how to choose between your busway types, specifically plug-in versus feeder. Now, I know it sounds like a totally standard run-of-the-mill routing choice, right? But as we're going to discover today, getting this wrong can absolutely wreck your budget and completely derail a project timeline. So let's jump right into it. So here's the million-dollar question you've got to ask yourself. Did you actually choose the right busway before freezing your BOM, your bill of materials? Our sources highlight this as the absolute point of no return in any major facility upgrade. Because once that BOM is frozen, walking back a fundamental infrastructure decision like this, it becomes a total logistical nightmare, full of massive financial penalties and cascading project delays. And this quote right from our source material brilliantly illustrates the real risk here. It points out that choosing the wrong type means, and I quote, paying for flexibility you don't need or installing a route that can't serve the loads you have. It's literally the perfect summary of the two giant traps you can fall into. You're either going to over-engineer the whole thing and blow your budget on a super adaptable system for a totally static environment, or, worse, you under-engineer it and completely throttle your facility's ability to even operate because you just can't get power to where you actually need it. Okay, so here's our roadmap for today. We'll start with that crucial choice before freezing the BOM, then break down the core engineering differences. After that, we'll look at exactly when the feeder busway wins, when the plug-in busway wins, and finally wrap things up with a rock-solid procurement checklist and industry standards. Let's start by digging into that first crucial choice you have to make before the BOM gets locked in. We have got to clear up a massive misconception right away. Plug-in and feeder busways are absolutely not interchangeable. Our research clearly shows they aren't just two different marketing buzzwords for the same metal box full of copper or aluminum bars. No, they serve completely different architectural purposes. Honestly, treating them as the exact same thing during your early planning phase is exactly how projects get hopelessly trapped. It is a definitive fork in the road for your entire project design. Which brings us to the core engineering differences between the two. The source material frames this choice as a really clear binary. On one side, you have the feeder busway, right? This carries current directly end-to-end with zero interruptions. Think of it like a heavy-duty, high-speed highway with absolutely no exits. But then on the other side, the plug-in busway relies on very specific, planned tap-off points distributed all along the run. So this is way more like a busy downtown avenue with cross streets everywhere. One is strictly built for bulk transport, and the other is all about localized distribution. So, what does this foundational electrical difference actually mean for you down the line? Well, the downstream impacts on project management are huge. For a feeder busway, your BOM complexity stays incredibly low. You really just need the main trunk and the fittings to navigate the building's geometry. Installation is super straightforward and your spatial clearance can be pretty tight. But switch over to a plug-in busway and that BOM complexity skyrockets. You're suddenly dealing with various top-off boxes and highly specialized joints. And crucially, your access clearance has to be significantly larger, so future technicians can safely get in there to plug in or remove a tap-off box. Seriously, if you cram a plug-in busway right up against a ceiling with zero clearance, you've completely defeated its entire purpose. All right, let's talk real-world application. When does the feeder busway actually win? According to the schematics in our sources, there are some clear, undeniable winners for the feeder busway. First up, transformer feeders. Connecting the main transformer directly to the main switchgear is just about moving bolt power safely and efficiently. No need to overcomplicate it. Next are risers. These create fixed backbones straight up through the floors of a high-rise. And finally, space-constrained routes. Because you don't need to leave room for future tap-off boxes, feeder busways can be tucked away super efficiently in tight utility shafts and ceiling plenums, which, as we all know, saves incredibly valuable real estate. But let's flip the script. When exactly should you be choosing the plug-in? Well, if your facility needs to breathe, adapt, and evolve over time, plug-in is absolutely the answer. Think about production lines and machine rows on a bustling factory floor. The layout you have today might need to be completely ripped up and changed next year for a brand new product line. By using overhead plug-in busways, you literally just move the tap-off boxes to the new locations, no major rewiring required at all. It's a lifesaver. The same logic applies to tenant floors in commercial buildings, right? Different clients are going to have wildly different power needs over the building's lifespan. Basically, anywhere a layout is guaranteed to evolve, a plug-in busway easily pays for itself by eliminating future downtime.
Finally, let's lock in execution with a solid procurement checklist and industry standards.
When it is finally time to place that order, the sources strongly recommend breaking the entire system down sequentially. Step 1, trunk sections. This is your total linear footage. Step 2, joint packs. You need to count the exact number required to connect those trunks because they aren't always conveniently bundled together. Step 3, fittings. These are the elbows, the T's, and the flanged ends you'll need to navigate the actual building geometry. And step 4, which is specifically for that plug-in route, the tap-off boxes. Separating these distinct categories mentally and keeping them separated on your spreadsheet ensures absolutely nothing falls through the cracks.
And, getting all the parts right only matters if they actually meet rigorous, real-world industry standards. Top-tier manufacturers like Xinma, who produce these highly advanced systems for demanding environments like data centers and massive transit hubs, constantly emphasize verifying compliance. You really want to be looking for standards like IEC 61439-6, IEC 61537, NEMA VE1, and GB 31251. Seeing those specific benchmarks gives you the guarantee that the system, whether it's a high-capacity feeder or a super flexible plug-in, is actually going to withstand the mechanical stresses of its specific environment. So, I want to leave you with this somewhat provocative thought. Is your upcoming electrical layout built solely for today's rigid specs, or is it built for tomorrow's changing needs? Because answering the question of how to really choose between feeder and plug-in, well, it isn't just a technical electrical choice. It is a fundamental, strategic business decision. By applying this exact framework, you can freeze your BOM with absolute 100% confidence. Thanks so much for joining me on this explainer, and I really hope this helps you engineer a smarter, much more resilient facility. Catch you next time.